So in the physical sciences, we may want to use trigonometry, a familiar relationship between the sine of an angle, or the cos of an angle, or the tan of an angle, can give us information about the sides of a right-angled triangle. And we're familiar with this. We have SOHCAHTOA is the familiar mnemonic to help you to remember which goes into which. Now, we are, in this video, we're going to try and find a derivative for tan using the quotient rule, which we've previously derived. But before I do so, I just want to explore sine, cos and tan a second. You see, both of or all three of these are just functions that transform x into a new number y. And all of them can be run backwards, that we can go from y to find x again with the inverse of all of these functions. So for example, sine x, if sine x equals y, then the inverse sine of y will give x. Now this notation, sine to the minus 1, it's a notation that was introduced by John Herschel. It replaces an earlier notation that Lagrange used, which was arc sine or arc cos, which you may see reference to still. But just be really careful, this is just the inverse process. Having something to the power of -1 in the rest of mathematics normally means the reciprocal of that thing. Now this does not mean the reciprocal of sine y, it means the inverse process of sine x. So just be very careful. The reciprocals of these functions have got, well, they are themselves functions. And the reciprocal, for example, of sine is cosecant, and the reciprocal, and that is equal to 1 over sine. And for cos, it is secant, and that is equal to 1 over cos. And we have cotangent, which is 1 over tan. Each of these are a function in their own right. And it's important that we know the names of those, because we may find that very soon these will be important to us. So, tangent. How do we find what the derivative of tangent is? Well, straight away let's go in that y equals tan x. Well, tangent, it turns out, is simply a ratio. It's a ratio of what the other two circular functions are doing. The ratio of sine x to cos x. That is all that tangent means. It's just the ratio of this to that. Sine x to cos x. And so if we want to work out what the derivative of this is, we need to use the quotient rule. So remembering what the quotient rule was, that if y equals u over v, then dy by dx is going to be 1 over v squared u times dv by dx minus v times du by dx. Alrighty then, and that gives us a really formulaic way. We just need to insert some values here. So going back up to u being equal to sine x and v being equal to cos x, and remembering what the derivatives of those two functions were, then we can rewrite this function in the following way. V squared would be 1 over cos squared x u, which is cos x, plus the derivative of v. The derivative of v would be also cos x, minus sine x multiplied by minus sine x. And of course we have two negatives here, so that would become a positive. 1 over cos squared x, cos squared x plus sine squared x. Now there is an identity, a trigonometric identity, which is going to simplify this for us. Cos squared x plus sine squared x actually equals 1. And so, therefore, the entire top part of this equation just equals 1. And so the dy by dx, or the derivative just simply becomes 1 over cos squared x. Now 1 over cos is equal to secant. It's that function over there. It's equal to sec. So 1 over cos squared x is actually equal to sec squared. So the derivative of tan is simply sec squared x. Now we don't tend to use this as much as the derivatives of sine and cos, but it's quite a nice derivation to work through, so I've included it here. Okay, whilst we're here, if we can work out what the derivative of tangent is, what would be the derivative of cotangent, 1 over tan? And we can simply just follow what we just did, but with cotangent in instead of tangent. So if y was equal to cot x, then rather than sine x divided by cos x, it would be 1 over that, cos x divided by sine x. So it would be cos x divided by sine x. And of course the quotient rule, which you may have noticed I wrote down ever so slightly wrong on the last video. It is v du by dx, and not u dv by dx as I wrote then, minus u dv by dx. So now it is just a straightforward case of substitution, and so we can do that very simply and quickly. 1 over sine squared x. Now v is this thing, so it is sine x multiplied by the first derivative of that thing, and cos goes to minus sine, minus, and then so we've got u, which is cos x, multiplied by the first derivative of v, which is this thing down here, which du, so it's u divided by v. First derivative of v with respect to x sine goes to cos, so it is cos x, which of course as before simplifies down. However, just notice what happens, there's an extra minus now, that this stays minus sine squared x minus cos squared x, and so this is going to not equal to 1 this time but to minus 1. Which means we're going to have minus 1 sine squared x. And so 1 over sine is cosecant, so 1 over sine x is equal to cosecant x. Then what we can say is this is equal to the first derivative of cot is equal to minus cosecant, or cosec as it's sometimes known, let's just shrink it down a little bit, cosec squared x. So that is the derivative of the inverse, or not the inverse, I should not say that, it's the derivative of the reciprocal of the tangent function.